Hello, everyone, and welcome. I'm excited to be here today to talk about how we're revolutionizing data workflows with Fabric pipelines. On this first slide, you'll see the title, Revolutionizing Data Workflows with Fabric Pipelines, and the subtitle, From Fragile Chains to Unified, Automated, and Resilient Data Orchestration. Over the course of this presentation, we'll explore how these new approaches are transforming the way we manage and automate data processes, making them more reliable and efficient. Let's dive in and see what this exciting journey is all about. Let's take a moment to remember the challenges of the old data workflows. In the past, we relied on a patchwork of tools and processes that made managing data quite difficult. The need for a unified, reliable orchestration solution really became clear. Without that, workflows were brittle and hard to maintain, often limited in visibility and prone to frequent downtime. This meant that when something went wrong, it was hard to pinpoint the issue quickly. Each failure was like a complex mystery to solve, and even successful runs felt like a small miracle. Data engineers depended on fragile chains of SQL agent jobs, PowerShell scripts, and various cloud schedulers, each one vulnerable to breaking. These outdated methods made workflows unreliable, and that's exactly what we wanted to improve with Fabric pipelines. Let's explore the new reality with Fabric orchestration. One of the key benefits is resilient recovery. This means that workflows are now self-healing, which significantly reduces downtime and the need for manual intervention. It allows teams to focus more on building and improving their data pipelines rather than constantly troubleshooting issues. This new approach empowers teams to create robust and scalable data pipelines with much greater ease. No matter how complex or large the data workload, Fabric helps simplify the management process. Next, let's talk about transparent monitoring. With built-in observability tools, you can track every execution of your workflows in real time. This visibility is crucial for identifying issues early and maintaining smooth operations. Finally, confident automation is a game changer. You can automate complex pipelines at scale through a visual interface, making it accessible even for those who aren't deep technical experts. And at the core of all this is the unified orchestration layer that Fabric introduces. It transforms how we manage data workflows, providing a centralized and seamless way to orchestrate all your data tasks. This integration really ties everything together and makes the entire process more efficient and reliable. So, what are Fabric pipelines? Essentially, they're a way to revolutionize how we manage our data workflows. This approach simplifies managing complex processes and makes everything much more transparent. Think of Fabric pipelines as the central nervous system for your data, coordinating every step smoothly and seamlessly. No more jumping between different tools or platforms. Everything connects, runs, and is visible in one place. It's all about unifying ingestion, transformation, and delivery tasks into a single, easy-to-understand visual canvas. This unified approach not only streamlines your workflows, but also gives you clear visibility into each stage, making your data processes more efficient and easier to oversee. Let's take a look at how Fabric pipelines are truly transforming data workflows. One of the key strengths is the ability to trigger external APIs, webhooks, and third-party services directly as part of your workflows. This means you can automate and connect to a wide range of tools and services seamlessly, making your data processes more integrated and efficient. Another important feature is the ability to chain notebooks, data flows, and lakehouses together within a single pipeline. This creates a smooth, end-to-end process that simplifies complex data operations and reduces the need for manual intervention. Fabric also offers a native integration that's built right into the platform, enabling you to connect various components without hassle. And with its drag-and-drop interface, you can build even complex workflows visually without writing a single line of orchestration code. This makes it accessible to a broader range of users and speeds up the development process. Overall, these core capabilities highlight how Fabric pipelines empower you to create more flexible, scalable, and automated data workflows, aligning perfectly with our goal of revolutionizing how we work with data. All right, let's walk through building your first pipeline in Fabric. To start, open your Fabric workspace and select New Pipeline. This is where the magic begins, and it's your gateway to automating data workflows. Next, you'll drag and drop various components like notebooks, data flows, and other activities onto the canvas. Think of this as laying out the steps in your data process visually. Once you have your components in place, you'll draw connections between them to define the execution flow. This step is crucial because it determines how data moves through your pipeline and ensures everything runs in the right order. After setting up the connections, you'll want to configure each activity, setting parameters, validating your configurations, and running initial tests. This helps catch any issues early and ensures your pipeline functions correctly before full deployment. Remember, the goal here is to create a seamless, efficient data workflow that can be easily managed and adjusted as needed. Building this pipeline is a foundational step in revolutionizing how you handle data, making processes more automated, reliable, and scalable within Fabric. Now, let's take a closer look at how advanced pipeline features like chaining notebooks and data flows are truly revolutionizing our data workflows. These tools are not just about automation. They're about fostering collaboration among team members. Whether you're a technical expert or a business user, these features enable everyone to contribute effectively to building and refining pipelines. When we talk about collaborative features in pipeline design, we're emphasizing flexibility. Notebooks and data flows support a modular approach, making it easier to develop and adapt workflows as needs evolve. This adaptability is key to staying agile in data projects. Focusing on data flows, they provide no-code or low-code transformations that are perfect for ETL tasks. This means business analysts and other non-technical users can participate in data preparation without needing to write complex code, significantly speeding up the process. On the other hand, notebooks serve as powerful transformation engines. They can be chained together by passing output parameters from one notebook as inputs to the next, creating a seamless flow. This modular chaining approach results in reusable, testable components that enhance both development speed and maintainability. Altogether, these features, chaining notebooks and data flows, are helping us build more flexible, collaborative, and efficient data workflows, aligning perfectly with our goal of making data work for everyone more effectively. Let's talk about incorporating conditional branching logic into our data workflows. This is a key way to prevent bad data from contaminating our processes while still keeping operations running smoothly. For example, imagine a pipeline that checks data quality scores right after ingestion. High scores can then proceed directly to production, while lower scores are routed to quarantine for review. This approach helps maintain data integrity without halting the entire pipeline. Another powerful concept here is loop constructs. These allow us to iterate dynamically over datasets or batches, making our workflows adaptable to varying data sizes or conditions. Then, with switch activities, we can manage multiple conditional paths efficiently, choosing the best route based on specific criteria. All of this ties into creating flexible, dynamic workflows using conditional logic. For instance, if-else conditions enable us to route execution based on data quality or specific business rules. This way, our pipelines become smarter and more resilient, ensuring that each piece of data is handled appropriately based on its context. Now, let's talk about parameterization for pipeline reusability. This is a crucial part of making our data workflows more efficient and scalable with Fabric pipelines. One of the first best practices is to use clear naming conventions, such as source container name, to keep our parameters understandable and easy to manage. It's also important to document the purpose of each parameter so anyone working on the pipeline can quickly grasp its role. Security is key, so always secure sensitive values by storing them in Azure Key Vault, which helps keep our data safe. A powerful approach is to use the same pipeline across different environments like development, testing, and production. We just change the parameter values, which makes deployment much simpler and more consistent. Reusing pipelines across different scenarios is made easier by referencing parameters within notebooks, data flows, and other activities, ensuring flexibility. We can also pass parameters directly to activities, such as dates, file paths, or configuration values, by creating pipeline-level parameters. Finally, defining parameters at the pipeline level allows us to control and customize behavior easily, making our workflows more adaptable and easier to maintain. All these practices together help us build robust, reusable, and secure data pipelines that align perfectly with the overall goal of streamlining our data processes. Now, let's talk about how scheduling pipelines can be triggered. One powerful way is through file arrival. So, when a new file shows up in your data lake or storage, the pipeline can automatically kick off. Similarly, pipelines can be triggered once a data flow refresh completes, ensuring that your downstream processes only run when the data is fresh and ready. External webhooks are another option, allowing real-time processing based on events happening outside your immediate environment. On the other hand, you can schedule pipelines using intervals or cron expressions. For example, you might want your pipeline to run daily at 2 a.m. or every 4 hours throughout the day. What's great is that these scheduling options handle complexities like time zones and daylight savings automatically, so you don't have to worry about manually adjusting your schedules. Now, when we compare event-based triggers and time-based triggers, think of event-based as reacting to specific occurrences, like a new file arriving or a webhook being called, making your workflows highly responsive. Time-based triggers, however, are more about planning ahead, running at fixed intervals or specific times, regardless of events. Both approaches are vital, and choosing between them depends on your data workflow needs. This flexibility really helps us build more dynamic and efficient data pipelines, fitting seamlessly into our overall goal of streamlining data workflows with Fabric pipelines. Now, let's talk about managing dependencies and preventing race conditions in our workflows. One key point is serializing operations that share resources or partition data for parallelism. For example, when multiple processes need to write to the same delta table, it's important to serialize those writes. This helps us avoid conflicts and prevents data corruption, ensuring data integrity. Next, we have the concept of preventing race conditions. This means designing our workflows so that each step proceeds to the next regardless of whether the previous step succeeded or failed. It's about maintaining the flow and making sure that one step doesn't block others unnecessarily. We also need to handle completion dependencies. These are about triggering error-handling paths if an activity fails, so we can respond promptly and appropriately. Conversely, failure dependencies ensure that the next activity only runs if the previous one was successful, which helps maintain the correct execution order. All of these dependency strategies, completion, failure, and success dependencies, are crucial for orchestrating workflows that are reliable and predictable. They help us control the execution sequence, prevent conflicts, and ensure that our data pipelines run smoothly and accurately. Now, let's explore how Cross-Workspace dependencies enable enterprise-scale data workflows with Fabric pipelines. First, we'll see that Workspace C focuses on publishing curated data to semantic models. This step is crucial because it allows us to facilitate scalable and modular enterprise data architectures, making it easier to manage and reuse data across different teams. Next, Workspace B takes raw data, processes it, and enriches it to turn basic information into meaningful insights. This transformation is vital for enabling smarter decision-making. Then, Workspace A is responsible for ingesting and staging raw data, preparing it for downstream processing. Think of it as the foundation that ensures data is ready to be worked on further down the line. Security is also a key aspect here. We use workspace-level permissions and leverage service principles to ensure secure data exchange between environments. This way, we maintain control and protect sensitive information as it moves across different parts of the organization. Finally, automation plays a big role in connecting these workspaces seamlessly. By enabling cross-workspace triggers and dependencies, We can automate workflows across isolated environments, making the entire data pipeline more efficient and integrated. Overall, these capabilities empower us to build robust, scalable, and secure data workflows that align with our enterprise goals. Now, let's look at how monitoring and auto-healing in Fabric pipelines truly revolutionize our data workflows. One of the key features is the ability to enable automatic recovery, which helps us minimize downtime and keep our processes running smoothly. This is where retry logic and self-healing come into play. If something fails, the system can often automatically attempt to fix itself without manual intervention. We also have automated alerts that notify our teams of failures, SLA breaches, or any custom conditions we've set up. This ensures we're always in the loop and can respond quickly to issues as they arise. To help us diagnose problems more effectively, we can visualize data flow and activity dependencies, which is invaluable for root cause analysis and ensuring compliance. When errors do occur, execution lineage allows us to pinpoint exactly where things went wrong, providing detailed stack traces and diagnostic information. This makes troubleshooting much more efficient. Failure tracking is another crucial aspect. It helps us identify bottlenecks and slow activities so we can optimize performance. Finally, detailed logs and duration metrics give us a comprehensive view of every run's execution history. All of these features together empower us to maintain robust, resilient data pipelines that adapt and recover seamlessly, aligning perfectly with our goal of creating reliable and efficient data workflows. Let's take a look at this real-world success story demonstrating how auto-healing can make a significant impact. As you can see, with this approach, we achieved 0% dashboard downtime, ensuring a seamless user experience. That means users could access their data without interruptions at all times. Compared to the traditional manual intervention, which could take over 4 hours to recover from an issue, our automated process brought recovery time down dramatically to just 45 minutes. This not only improves efficiency, but also minimizes disruption for end users. In terms of financial impact, we estimate savings of around $250,000 by avoiding delays in reporting, which can be critical during busy periods like peak seasons. Now, how did it work in practice? When the API upstream failed, auto-healing kicked in immediately. The pipeline automatically switched to a backup data source, keeping everything running smoothly. An alert was sent directly to the engineering team via Teams, so they knew about the issue right away. Within 45 minutes, the primary source was restored, and the pipeline resumed normal operation, all without manual intervention. This solution was implemented during a critical time for an e-commerce company, where a pipeline failure during peak season could have been disastrous. It highlights how resilient, automated systems can really transform data workflows and keep things running smoothly even when unexpected issues arise. Now, let's talk about how Fabric pipelines are revolutionizing data workflows by combining both batch and streaming layers. This hybrid approach allows us to get the best of both worlds, speed and accuracy. The real-time layer provides fast, approximate results, which are great for immediate insights, while the batch layer ensures we have accurate, comprehensive historical views. The serving layer then unifies these results, making it seamless to query data across different time frames. This setup is what we call the Lambda architecture. It processes data in fixed intervals, like hourly or daily, to make sure we have complete coverage without any gaps or overlaps. This is especially powerful for time series analytics and supports incremental loads, which means we can update our data incrementally without reprocessing everything from scratch. Now, moving on to tumbling windows, this pattern helps us process data in chunks of time, like every hour or day. It allows us to process multiple data sources in parallel, which is often called fan-out. After processing, we then merge the results. This is the fan-in step, to maximize throughput. This parallel processing approach is particularly effective when ingesting data from multiple APIs or databases at once. It ensures that our data pipeline remains efficient, scalable, and capable of handling high volumes of data with minimal delay. Finally, advanced orchestration patterns build on these concepts, helping us manage complex workflows more effectively. By orchestrating data processes smartly, we can ensure everything runs smoothly, dependencies are handled correctly, and our data pipelines stay reliable and performant. All of these concepts together empower us to build robust, high-speed, and accurate data workflows that meet the demands of modern analytics. Let's explore how we can optimize pipeline performance and manage costs effectively. First, one key technique is smart caching, which involves caching intermediate results that are reused by multiple activities. This way, we avoid redundant processing and save time. Next, data locality is crucial. By keeping processing close to where the data resides, we minimize transfer overhead, making the entire workflow more efficient. Matching compute resources to workload demands or activity right-sizing helps us prevent overprovisioning, which can be costly, and ensures we're using just the right amount of resources. Incremental processing is another powerful approach. Instead of reprocessing all data every time, we process only what's new or has changed, significantly reducing workload and time. Finally, running activities in parallel allows us to execute tasks independently at the same time, which can dramatically cut down the total duration of the pipeline. When we combine these strategies, we not only enhance performance, but also keep costs in check, aligning perfectly with the overall goal of building efficient, scalable data workflows with Fabric pipelines.